morning and happy Monday. I hope you guys had a good weekend. Today I'm going to do a quick video real quick to show you a page that I want you to put down in your notebook. This is something we've already talked about. I'm just giving you another page with some more detailed examples so you can refer back to this for your work today. Today your notes are titled One Solution, No Solution, Infinite Solutions. And this is when you're solving an equation and you're coming up with some sort of answer. And you have a Delta Math assignment today on how to justify what the right answer is. Why is this answer the right answer? Does it fit in the equation? Does it make sense? And we've looked at problems before where we go back and we plug it in. We make sure that it's true. But back here, when we were doing multi-step equations with variables on both sides, if you look down here at the bottom, I gave you some little notes that said sometimes there could be no solution, sometimes there could be infinite solutions. So like I said, we have talked about this before, but if you're working out an equation and you get down to your variable equaling some sort of number, like one specific number for that variable, then that means you have one solution. You have one answer that this variable could be in this equation, and you figured it out by solving and moving things around, by distributing, combining like terms on each side, and then moving your constants to one side, moving your variables to the other, and then getting things away from your variable. So here we had multiplication, so we got rid of that with division. And so this is all stuff that we've been working on for quite some time now. So we distribute, we combine like terms, and simplify, and then we do PEMDAS backwards once we have our variable on one side. And then I gave you down here an example of when you would have infinite solutions, and that would be when you have a number equal to the same number. So we worked this problem out. We moved the variables over here, and it canceled out, which left us with just 1 equals 1, meaning there's infinite solutions that this number could be. 2 times 4 plus 1 is equal to 2 times 4 plus 1. Well, what if x was 8? 2 times 8 plus 1 is equal to 2 times 8 plus 1. It will always be true because no matter what, the same thing is happening here. We can see that. But we also solved it and noticed that a number equaling the same number is true, which means you have infinite solutions. If you're working out an equation and you get your variables together, they cancel, and you get a number that is not equal to the same number, that's not true. We know for a fact that 4 is not 2. The equal sign represents the word is in math, right? So here I would say x is 1/2. That's what x is. So is 4 2? 4 is not 2. So it's not true. There's no solution. So, excuse me. For today's examples, I'm going to show you more specifically one of each. So when we're solving our equations, obviously when I say solve for x, it means that you need to get the variable alone. Nothing else needs to be on that side of the equation or that side of the equal sign but the variable. So usually what you guys do first is you distribute and simplify. If there's any terms on each side of the equal sign before we start moving, we combine them. And then we do PEMDAS in reverse. So we add or subtract those constants, and then we get rid of whatever's stuck to our variable by multiplying or dividing. So in this equation, this is an example of one solution, meaning x is equal to a number. We have 5x plus 3 equals x plus 23. So the first thing I did, there's nothing to distribute or combine on each side. Nothing is similar. Like nothing over here can be combined with each other, and nothing over here can be combined with each other. So I'm just going to start moving. So I moved this x over here. So the opposite of positive x is negative x, so I just subtract. That's now gone, and now I have 4x over here because 5x minus x, these are like terms, I can combine those, I get to 4x. Bring down plus 3, bring down equals, bring down 23. So the first step I did was I moved my variables. Next, I'm going to subtract. The second step, I'll subtract this constant away, because remember, we want to do PEMDAS backwards. So the opposite of plus 3 is minus 3. Do that to both sides. And then I bring down 4x equals 20. And then I have to get rid of this 4 that's being multiplied to this x. So I divide by 4 to both sides. That's my last step. And I get x equals 5. So that's just one solution. X is one number. X is 5. Now, an example of no solution would be a number that cannot be equal to a different number. So that's just not true. That's not a true statement. So in this example, -3 times -5y minus 1, close parentheses, minus 15y equals -8. So the first thing I do is I distribute. So I wrote my steps out to the side so you can see. I distributed -3 times -5y. So if we just look at the numbers, -3 times -5 is positive 15. We know two negatives make a positive. And I have to bring that y down with it. Okay, and then -3 times -1 is positive 3. And then I bring down the -15y, bring down the equal sign, and bring down the -8. At this point, I could just combine like terms. So over here on this side of the equal sign, I have a positive 15y and a negative 15y. They're both talking about y's to the first degree, so I can combine them. But positive 15 and negative 15 give me 0. So they actually just cancel each other out, which is fine. Don't freak out if you see that. So what I'm left with to bring down is positive 3 equals -8. I know for a fact that 3 is not -8. It does not equal -8. 3 can only equal 3. It's the only thing that 3 is. It can't be any other number or else it's not 3 anymore. So this is not a true statement, which means that there's no solution. There's no number that you can put in there to make this true. Like, this isn't going to work. And then our last example would be one that has infinite solutions, meaning you'll get the number equal to the exact same number, which means you could really plug any number in there because it's going to work. It's very true. So here we have the equation 3 times -5y plus 22, close parentheses, plus 15y equals 66. So obviously first I distribute. 3 times -5 is -15, bring down the y. 3 times positive 22 is positive 26. Then I bring down the 15y, bring down the equal sign, and bring down 66. Again, I'm seeing the same thing. I can combine these like terms, but if I look at the value, -15 and positive 15 just give me 0, which only leaves 66 equals 66, which is a true statement, which means no matter what number I plug in here, they'll end up canceling each other out. So I'll always end up with 66 equals 66. So there's infinite numbers I could plug in for these letters, which means there's infinite solutions. So if you get a number equal to the same number, it's infinite solutions. If you get a number equal to a different number that's not true, it's no solution. And if you get a letter equal to a number, it's one solution. So those are your notes for today, and I'll upload a picture of those so that you can either print that or just look at that and copy that down in your notes better. And then you're going to go to deltamath.com and work on your assignment for today. Again, it'll ask you questions like, which equation justifies the solution x equals 2? And you'll have to look at the equation and say, okay, if x is 2 and I plug 2 in, will it make it true? Does it come out to be a solution or not? Or it may say, in this equation, what would the right answer be to justify this equation being true? And you would have to plug it in. So it's going to ask you questions about that. And then there's a few questions it's going to ask you, in this equation, is the answer one solution, no solution, or infinite solutions? So you would have to solve the equation, see what kind of answer you get, and choose either one solution, no solution, or many. So please use your notes on today's Delta Math assignment. Take your time, work through it. And remember that you have a test this Friday, so everything that we're doing this week is really important, along with everything that we've done so far for this unit. So make sure that you've gone back and checked your work and turned in anything that you can still turn in for a late grade, as long as it's not too far behind. And look through your notebook. Like I said, this is something we've already talked about a few pages back. Here, it was very quickly kind of overviewed. But this isn't something that's totally new. So if you're just going through your notes and looking back at everything that you have, you should be good to go for the test. So make sure that you're always looking back through your notebook. And that's why I give you guys this notebook, because if you're having to scroll through Google Classroom for weeks at a time to find the important notes, you'll get very lost. But if you have them written down in a notebook, you can just go through and look at the important things that are in this notebook that you need to review. So it's super helpful. So good luck on today's assignment, and I'll talk to you guys later.